Hi, this is MC sir. Today we have to discuss small points ST, VT and AT graph. After this class, we have to subscribe our channel. Okay, here just identify ST, VT and AT graph. So almost three graphical representations are same only, but we have to compare that three graphical representation. Here displacement time graph, slope parallel to time axis. In the second condition, velocity time graph, slope parallel to time axis. Acceleration time graph, slope parallel to time axis. These three diagrams we have to identify slope parallel to time axis. Are you identify this point? Okay, but here displacement time graph slope parallel to time axis, then body is at rest only. Body is at a rest. What is the velocity? Velocity equal to 0 meter per second. What is the reason? Here slope angle theta equal to 0 degree. Already explained this point. Tan theta equal to ds by dt. Okay, tan 0 degree value how much? 0. ds by dt, the rate of change of displacement is called as velocity. Yes or no? So here velocity equal to 0 meter per second. Understood? So this point is very important. Okay, but what about second condition? In the second condition, velocity time graph slope parallel to time axis. Here we have to represent slope formula. Slope equal to dv by dt. dv by dt. The rate of change of velocity is called as acceleration. Okay, so formula for tan theta. Okay, tan theta here, just observe here tan 0 degree. Okay, tan 0 degree, then dv by dt is equal to acceleration. Tan 0 degree value how much? 0. Therefore, acceleration equal to 0 meter per second square. But here body is moving with constant velocity. Body is moving with constant velocity. Okay, so it is very important note point. If velocity equal to constant, then acceleration equal to 0. Okay, don't forget. So now here identify velocity time graph slope parallel to time axis, then velocity equal to constant, then acceleration value equal to 0. Okay, velocity time graph slope is represent acceleration. You have any doubt? No doubts for you. So next we have to go to acceleration and a time graph. Okay, here acceleration time graph slope parallel to time axis. In this graphical representation, we have to find that slope is equal to dA by dt. The rate of change of acceleration, there is no formula. Okay, so it is nothing is represent. Okay, dA by dt is not equal to anything. It's not equal to anything. You have to identify this point, very important point. And next one, just identify that one more condition for you. Okay, here slope angle how much? 0 degree. Angle of slope 0 degree. So tan 0 degree. Tan 0 degree equal to dA by dt. Okay, dA by dt. Okay, na? Understood? But dA is equal to 0 into dt. But integral dA equal to integral 0 into dt. Integral dA equal to integral 0 into dt, that is equal to acceleration constant. Acceleration constant. We have to apply this integration method. Okay, so already explained this point in a previous introduction class. Okay, so here d by dx of constant equal to 0, but dc equal to 0 into dx. Okay, we have to find out that c. So c means 1 by d into 0 into dx. 1 by d nothing but integral Yes or no? So in integration we have to use that condition. Okay, integral 0 dx. Integral 0 dx equal to constant value. Okay, here integral 0 into dt equal to constant. Which value constant? Acceleration. Here acceleration, so it is possible in this condition only. Because of that reason, acceleration equal to constant. Acceleration equal to constant. Not this point. Very very important point. Okay, and next have to observe that three conditions. Okay, so in third condition, acceleration equal to constant. Okay, in these three cases, we have to discuss one more point. What is that point? Yeah, displacement, time graph, slope under the area. So displacement, time graph, slope under the area we have to represent. So what is that shape? The shape of this area rectangle. Okay, what is the formula for rectangle? Length into breadth. Yes or no? So here generally formula for area equal to length into breadth. Okay, here length value represents t, breadth value represents displacement. Yes or no? Displacement to time. Displacement to time. Displacement to time not equal to anything. Don't forget. There is no formula. Okay, displacement time graph not equal to anything. So there is no formula. Due to that reason, no need to discuss that point for this condition. But so in second condition, we have to identify this point. This is very very important point. I saw this point in many examination. Velocity time graph slope under the area. Velocity time graph slope under the area is represent displacement. So just identify. Velocity time graph slope under the area is represent total displacement. So here just identify that what is the formula for area? Length into breadth. Here length value time, breadth value velocity. Velocity into time, that is equal to displacement. So right here velocity into time, that is equal to displacement. Yes or no? So it's very very important point. Velocity time graph slope under the area is represent total displacement of a body. Okay, MP, important point. Okay, but in third condition, you have to observe your acceleration time graph slope under the area. Okay, acceleration time graph slope under the area is represent change in velocity. Is represent change in velocity. Okay, just identify that equation of acceleration formula. Okay, formula for acceleration formula A equal to V minus U by T, but V minus U equal to AT. Here length value represented T, breadth value represented acceleration. Yes or no? Here now here we have to find out that slope under the area. So then we are getting that value is acceleration into time. Acceleration into time equal to how much? V minus U. What is the shape? Rectangle. Okay, what is the area of rectangle? Length into breadth. Okay, so length value time, breadth value acceleration values. Then multiply acceleration into time. Acceleration into time, that is equal to V minus U. Understood? So we have to define this condition. Acceleration time graph slope under the area is represent change in velocity. Do you have any doubt? No doubts. So you have to observe these three conditions. Okay, very very important points. Next, we have to discuss in the second case. Almost these three graphical representations are same only. But what is the difference? What is the difference? Displacement time graph slope straight line from origin. Here velocity time graph slope straight line from origin. Acceleration time graph slope straight line from origin. Okay, just identify displacement time graph slope straight line from origin. Here slope angle constant. Which one constant? Slope angle constant. Theta equal to constant. Okay, are you understood? Theta value equal to constant. So tan theta equal to constant. Tan theta formula, tan theta equal to ds by dt, that is equal to velocity, that is equal to constant. Understood? Okay, so here theta value constant, tan theta equal to constant, tan theta equal ds by dt, that is equal to v equal to constant. Rate of change of displacement is called as velocity, that velocity value equal to constant value. Okay, in the next condition, velocity time graph slope is represent straight line from origin. This slope is represent, what is that slope angle? Slope angle is constant only. Okay, we have to apply condition here, tan theta equal to constant. Tan theta equal to constant, then formula for tan theta is equal to dv by dt, the rate of change of velocity. Okay, the rate of change of velocity equal to acceleration. Okay, acceleration equal to constant. Understood? Here velocity time graph slope straight line from the origin, then that slope is represent to constant acceleration. You have any doubt? No doubts. Okay, therefore acceleration equal to constant. Okay, in third condition, you have to identify acceleration time graph slope straight line from origin, then that slope is represent. Okay, so just identify. So here theta value fixed only, tan theta equal to dA by dt. Okay, here dA by dt value constant, dA by dt value constant, but there is no formula. There is no formula, it cannot indicate any physical quantity. Understood? dA by dt equal to constant. Okay, but it is not represent anything. Okay, so it's very important point. dA by dt, there is no formula. There is no formula. Okay, identify this point, very important point. dA by dt, there is no formula. Next, second one, we have to find out that slope under the area for each graph. Displacement time graph slope under the area. Here, what is that slope under the area? Slope under the area is represent nothing for displacement time graph. Okay, so there is no formula. Displacement time graph formula is equal to nothing. But here we can identify that graphical representation, velocity time graph. Okay, velocity into time equal to displacement. Yes or no? So what is that shape of displacement? Sorry, what is the shape of this area? Right angle triangle. What is that shape of area? Right angle triangle. What is the formula for area of right angle triangle? So area of right angle triangle, half into base into height. Half into base into height. 1 by 2 base value. Base value represent time, height value is represent velocity. Velocity into time, that is equal to displacement divided by 2. So finally it represent displacement only. Displacement divided by 2 is nothing but displacement only. Okay, are you understood? Don't forget this point. Okay, total here, no need this point, you have to remove. Displacement, here area equal to displacement, that is equal to half into base into height, that is equal to 1 by 2 velocity into time. So here area is represent total displacement of a body. The total displacement of a body equal to how much? Half into velocity into time. Okay, no need discussing about this point, leave it. Okay, it is also right point only. Okay, don't forget, it is also right, but no need that point in this explanation. Okay, you can leave it. And next one, acceleration time graph. Acceleration, time graph, slope, straight line from origin. Okay, acceleration, time graph, slope under the area is represent change in velocity. Okay, that shape of area is represent area of right angle triangle. Okay, area of right angle triangle formula, change in velocity v minus u, base half into base into height. Yes or no? Half into base into height, 1 by 2 base value time height value is represented acceleration a into t. Okay, are you understood? Change in velocity how much? V minus u equal to half acceleration into time. You have any doubt? No doubt for you. So these points are very important in examination. And next we have to come three graphical representations. So first one, second one and third one. ST graph, VT graph and third one AT graph. In ST graph we have to identify displacement, time graph, slope, curved line from origin. Yes or no? Here slope angle constant or variable? Here slope angle constant. We have to consider that at this point slope angle theta. So theta 1, another point we have to identify that. Okay, it is theta 2. One more point we have to identify. It is represent to theta 3. In every point we have to observe that theta value is not same only. Okay, here theta angle of slope is gradually increasing. Angle of slope is gradually increasing. So you have to represent tan theta equal to variable quantity. Tan theta equal to variable quantity. So here angle of slope is a variable quantity, then you have to apply that formula tan theta equal to ds by dt. ds by dt, that is equal to velocity. That is equal to velocity. Okay, then we have to give that conclusion, velocity equal to variable quantity. Okay, understood. It is variable and this velocity is increasing velocity. Which velocity it is? So increasing velocity. In the second condition, you have to identify velocity, time graph, slope, straight line from origin. Velocity, time graph, not straight line, it is a curved line. Velocity, time graph, slope, curved line from origin. Okay, here identify that slope angles. Theta 1 and another observation point we have to identify theta 2. One more observation point we have to identify theta 3. At every observation point we have to identify that the angle is gradually increase. Yes or no? Due to that reason here angle of slope variable, tan theta equal to variable. Okay, tan theta equal to dv by dt. Tan theta equal to dv by dt. The rate of change of velocity is called as acceleration. Okay, that acceleration is not equal to constant. Is not equal to constant means it is a variable. Okay, na? Do you have any doubt? Okay, so in third condition, acceleration, time graph, slope. Acceleration, time graph, slope is also represent that previous conditions. Here we have to consider that angle theta 1 and another observation point we have to calculate that angle theta 2. Okay, one more observation point on slope we have to consider. At this point we have to find out that theta 3. At every observation point we have to draw one horizontal line, then you can calculate that angle of slope. That angle of slope is not constant. Okay, so same method we have to apply. Tan theta equal to variable. Okay, so tan theta equal to dA by dt. dA by dt. Okay, that is equal to nothing, variable only. Okay, variable. dA by the rate of change of acceleration. The rate of change of acceleration is not constant. The rate of change of acceleration is not constant, it is a variable only. Okay, do you have any doubt? No doubts for you. Okay, so we have to observe this ST, VT and AT graph a few seconds So after that, students, you can subscribe my channel so for next class and give comments. Okay, students, bye.